Okay, all right. Good afternoon, everyone, once again. This is last but not least for the next topic is degradation during mixing of silica reinforced natural rubber compounds that is really matter. Please welcome Dr. Ammarin Kraibut, ค่ะ all speaker.
Thank you very much for sharing for a nice introduction. First of all, good afternoon, everyone. Thank you very much for joining my presentation. First and foremost, I would like to express my gratitude to the organizer of GRTE for inviting me to join this conference. It's very nice. I'm very glad to join and present more my work. Today, my topic is degradation during mixing of silica reinforced natural rubber compounds. That is really matter. I hope this will benefit for the manufacturer, especially in the compounder. And for my research, is based type train model compound. That is why I also hope that it will benefit for the tire company. For my research is focused in a few natural rubber compounds. That is mean I would like everyone to understand about natural rubber first. That natural rubber is a sustainable and renewable material, of course. That is very is everybody know. And another advantage point then is very good in the mechanical property, but we understand that it cannot use in the form of unfilled or pure form. This means it needs to mix together with the reinforcing filler for to achieve the property. This means we understand that reinforcing filler, there are two kinds of reinforcing filler that we understand in the market. First, silica, and another one, carbon black. What are the different characteristics? It's quite a long history for carbon black. Everybody know. Carbon black, the main component is carbon with the small component or percentage of the oxygen containing functionality. This means we can call that carbon black is a relative non-polar surface. It's good compatible with natural rubber. This because of natural rubber is non-polar rubber. However, in case of silica, you will see in the structure that it consists of the hydroxyl group on the silica surface. That means the characteristic of silica is the high polarity. It's not compatible with the non-polar rubber like the natural rubber. There are several studies about how to improve the compatibility between silica and rubber. Everybody know that in the tire industry or compounder, we always use the commercial silane. That the one can improve the compatibility between silica and rubber, natural rubber. And however, this process needs to make at high temperature. This is very key important things because we need to achieve sufficient salinization. What is the sufficient salinization? Is the reaction between hydroxyl group on the silica surface and ethoxyl group of silane. This process can reduce the filler-filler interaction and make the better dispersion of silica in the rubber matrix. This is one important thing. Then when you continue the mixing, it will increase rubber filler coupling. This is one point that make the compatibility between silica and natural rubber. However, as I told you, this need to make at high temperature. What happened? It's well known. Natural rubber is prone to degradation. Why? This because of the reactive allylic carbon on the silica on natural rubber structure. That the one that make the inferior property of natural rubber. How we know? There are findings from previous work. You will see the one from the property in case of natural from the field compound. You will see mono viscosity decrease after damp temperature over 150 degrees Celsius. However, in case of vulcanized property as well, you will see tear resistance gradually drop after mix or damp temperature over 150 degrees Celsius. That's why we raise the question. What are the mechanisms behind it? This is one important thing for my purpose, that I would like to know the degradation phenomena in different conditions. That's why come to the methodology that it consists of the gum compound, this unfilled. This means you can know that for the molecular chain modification during mixing. I use the reference to be the gum compound. Then for few natural rubber compounds, as I told you, it's base truck type model compounds. Then there are two mixing procedures. The first, for fill factor 0.7, I use the mixture temperature setting 40 to 145 degrees Celsius by variation of rotor speed 50 to 80 RPM to achieve the compound with several conditions from 100 to 170 degrees Celsius. This is the first master batch that I will test for the uncured compound. Then this compound, I will continue to prepare for the second step. For the second step, I use the same condition that use fill factor 0.7 with mixer temperature setting 70 degrees Celsius. Come to the methodology about the characterization for uncured compound from master batch. I mean the master batch from the first mixing step. I test ammonia viscosity. And another one that important thing, I would like to, because of natural rubber is viscoelastic material, I would like to test or measure the viscoelastic property. We can observe and then check the chains of dynamic response. Because of viscoelastic, there are two kind of behavior. First is combination between elastic and viscous behavior. When degradation happen or increase, of course, the chain of elastic and viscous response also will change. This means there are anything happen with this ratio. For I will use for two methods like the Mooney sweat relaxation by Mooney viscometer, and another one dynamic property measure as frequency by using rubber process analyzer, and including Montech as well. I use this machine. And another one that one condensate property, I also go to test mechanical property to verify the final property. I'm gonna go to show for the first result with mechanical property, because you will see the different property with in different condition. In different condition, it means different dump temperature. We observe they are the same finding from previous work, that the tensile strength and elongation at break gradually decrease when dump temperature over 150 degrees Celsius. That's why we raise the question, what happened above the temperature over 150 degrees Celsius? We expect maybe it's because of rubber chain or natural rubber degradation. And because we use the silica, we would like to know what happened for this filler rubber interaction and filler interaction. All this inferior property is come from another key ingredient. That's why we raise the question to figure out. The first two that I'm going to show everyone that I would like to measure to investigate the rubber degradation. I use Mooney sweat relaxation. For this measurement, it's like it's combination, as I told you, viscoelastic material. It's combination between elastic and viscous response. Mooney sweat relaxation also can indicate that one. Higher relaxation rate, it indicate increase in viscous and elastic ratio. How we can get this data? I can get this data after I measure Mooney viscosity. It means after 1 minute preheat and 4 minutes you get Mooney viscosity. And then we stop rotor, and then Mooney viscometer will detect the torque. We will use this torque to plot the relation between Mooney unit by function of time by using power law model. And you will see it is for the figure, it is a log expression. This means A from the equation. This means this slope. Slope is mean Mooney sweat relaxation rate. For Mooney sweat relaxation, as I told you, higher relaxation rate indicate increase in viscous and elastic ratio. Viscous behavior increase. What that happen? It means the degree of degradation increase. I'm going to show for the first result for pure NR and gum compound that is the reference compound. Go for the first condition 120 to 140 degrees Celsius. You will see increase of the Mooney viscosity. On the other hand, Mooney sweat relaxation decrease. This because of we observe from preliminary from branch formation, long chain branch formation, and then you also can observe that when dump temperature over during 140 to 165 degrees Celsius, Mooney viscosity of the gum compound is higher than PLNR. What happened? This because of effect of anti-degradant and that protect the degradation process. When we observe dump temperature 150 to 165 degrees Celsius, what happened here? And then you will see drastically drop of the viscosity. This because of transition overrule branch formation. On the other hand, you will see leveling off of Mooney's rate relaxation. This because degradation happen. There are two forms like they generate the short chain, and another one like the chain recombination. Chain recombination will provide long chain branching. I'm going to go show for the other compound like fuel compound, that the study compound. When we observe dump temperature 120 to 140 degrees Celsius, you will see increase of Mooney viscosity. On the other hand, or Mooney sweat relaxation decrease. This because of it showed that when you increase dump temperature, it will provide the better salinization. It means reduce filler-filler interaction, as I told you in the beginning, then resulting in more silica rubber coupling that increase filler rubber interaction. This is the nominal effect for the dump temperature 120 to 140 degrees Celsius. But when you observe over 140 degrees Celsius, they are shown the leveling of the Mooney viscosity and Mooney sweat relaxation. This because of counterbalance of salinization, filler rubber coupling, and degradation. That's why, according from these results, I can tell everybody that during mixing, there are competitive reaction. First, this is a positive effect like salinization. Salinization will produce when higher degree of salinization, it will decrease filler-filler interaction. What happens when better or decrease of filler-filler interaction? That means it will give the better dispersion that the one and the first good. And another one, when you continue mixing, of course, it will show the rubber filler coupling. And another one that another effect, like as I told you, competitive effect. The other one is a negative. That is the degradation. Degradation, as I told you, is shown for the chain scission and chain recombination. Chain recombination is shown in the form of long chain branching. That's why we would like to confirm that I told you that Mooney sweat relaxation show something like the increase of long chain branching. That's why we need to use another tool to verify and prove formation of long chain branching. That's I use a both concept from dynamic response, dynamic measurement. You will see I get the information from phase angle by frequency shift that I test with the RPA. That you will see I used from both concept. They said that they are the delta that indicate the degree of the long chain branching. How we can get delta? Delta is come from the phase angle at low frequency and high frequency. This because of at low frequency, phase angle is highly sensitive to branching. But on the other hand, at high frequency, phase angle primarily determined by short range segment. That's why we need to use the whole range for indicate degree of long chain branching. When delta decrease, what happened? This can indicate molecular weight distribution and long chain branching increase. When long chain branching is increase, what happened? The chain mobility decrease. That's the one point. That's why this measuring or this tool we can use to prove of the branch formation. I'm going to show everyone for the first result with pure and gum compound. You will see when we increase dump temperature, what happened? Delta decrease. That we can verify that the increase of the formation of long chain branching. Then in case of few compound, what happened? You will see it's a lower degree delta in a higher value when compared with the pure. This because of solid coupling formation because of silica, silane, and polymer coupling. And this is the one reason. And you will see when we increase dump temperature, this because of slightly crossing formation make the lower chain mobility and silica silane polymer three-dimensional network that reflect as a bland formation. That's why they have double. It's a one long chain branching in the only natural rubber structure that is a chain modification during mixing, and another one that silica silane coupling with the rubber, natural rubber, and that reflect as the band formation. That's why we can show what happened in the mechanical property. Dump temperature 120 to 150 degrees Celsius. There are enhanced filler rubber interaction, and salinization coupling reaction overrule the effect of chain branching or degradation. However, in case of dump temperature 150 to 165 degrees Celsius, what happened? This drastically drop off tensile strength and elongation at break. This because of salinization is optimal and silica rubber coupling gradually increase. The above reactions are overruled by chain scission, and finally result the formation of long chain branching and chain scission lead to the imperfection of network structure and resulting in inferior property. From this project, we can conclude that there are competitive reactions during mixing of the silica, silane, and natural rubber at high temperature. The positive effect is the salinization and coupling reaction. For the negative effect, what happened? Is the rubber degradation that make inferior mechanical property. And for silica film natural rubber, dump temperature condition like 140 to 150 degrees Celsius is a sufficient degree of salinization, and it is a limited amounts of degradation. This because of formation and counterbalance by filler rubber coupling. The last one, we can conclude when dump temperature over 150 degrees Celsius, there are chain scission overrule filler rubber interaction, and formation of the chain from long chain branching and chain scission lead to the network imperfection and resulting in inferior mechanical property. Finally, I would like to thank the Netherlands Natural Rubber Foundation and Prince of Songkran University PhD scholarship to support for financial support, and my colleague in elastomer technology and engineering ETE group in the Netherlands for many support, and including my colleague in the polymer technology program, Department of Rubber Technology and Polymer Science from Prince of Songkran University. Thank you everyone for your kind attention.
Thank you so much for Dr. Ammarin. Anyone have any question? Still have time? Okay, all right.
Hi, thank you for your presentation. My name is Riyash from Rubber Incorporated in South Africa. On your formulation, I noticed your coupling agent is silane to silica. I want to find out what's the effects of including polyethylene glycol, PEG 4000. Will that have any degradation in terms of the natural rubber, and what effect will that have on the dump temperature?
Yeah, thank you very much for your nice question. If I understand correctly, you mean what happened if we add it in formulation has the PEG, right? In the rubber formulation, with when dump temperature in different condition like this. First of all, I would like to explain everyone for the purpose of PEG, that normally they would like to make compatible between the silica and natural rubber. as I told you in the beginning. In the past or in the old technology, silica technology, we add this one to make the compatibility between both of them. Yeah, nowadays we have the new silica technology by using commercial silane like TSPT and TSPT to make like the coupling agent to make compatibility between silica and natural rubber because of both of them like incompatible. Silica is a polar filler, and natural rubber is a non-polar rubber. That's why we need coupling agent. But in the past we used PEG, but nowadays you don't need to use it. But in case of you use PEG in the compound, what happened? PEG is like the if you add in the compound with certain amount, it's fine. However, if we make softer of the material, like the final sample, one can I say sample, because of the PEG is like the processing oil or processed oil. This means it may make the low modulus. That the one that we can you can observe in the literature as well. PEG when you add more, it will make the inferior mechanical property as well. That's because of PEG, as I told you, is make like the processing oil or like the plasticizer. What happened then? It will move or insert in between the natural rubber molecule. That means the natural rubber chain can move easier move for movement, and then it's make like the inferior mechanical property when you test it. That the one important things that you might know. However, I'm not sure that for the PEG is what is the melting point or like you evaluate point. That if 100, if you mix at 100 over 150, okay, is evaporate. However, the one important even it evaporate, but over 150, the mechanical property is going down. That the one that you also need to mind. Yes.
Anyone have any question? Okay, if it's no question now, so thank you so much once again. That is joy and to be our speaker, and thank you for the audience. And there are more interesting topics for tomorrow, and we will start at 11 here at the conference room 1. So hope to see you again tomorrow. Thank you, and please enjoy the exhibition. Thank you so much.
ไม่ถ่ายรูปอะไรใช่ไหม